Now let's do the next part of this chapter, and this may be the last, I think. So we have done with the potassium dichromate. Now we are going to do some more topics from this chapter. The next one is potassium permanganate. So, but potassium permanganate is also a good oxidizing agent. It is formed from potassium magnate. Okay, so let's see. So the ore is pyrolusite manganese dioxide. It is prepared from pyrolusite. Okay, so it is a purple color solid potassium permanganate. How you can remember the name? See here, permanganate. Per is coming in the permanganate and per is also coming in purple. So this is the trick to remember the color of potassium permanganate. Potassium permanganate is purple in color. Okay, it is a solid. Now next, how to prepare potassium permanganate. Conversion of pyrolusite ore to potassium manganate. So 2MnO2 plus 4KOH plus O2 will give 2K2MnO4 plus 2H2O. It is dark green in color. So see, it is not permanganate, it is manganate. So pyrolusite, on adding KOH to pyrolusite, and we will get a dark green color component which is K2MnO4. It is known as potassium manganate. Let's do it. Now the disproportionation in neutral or acidic medium will take place for potassium manganate, which is MnO4 minus. See the oxidation state of this compound. It will be plus 6. How plus 6? O4 minus 8 plus 2. So this is minus 6 means plus 6. Mn is plus 6 oxidation state. So it will disproportionate in neutral or acidic medium to give you MnO4 minus MnO2 plus 2H2O. Next, let's move ahead. So MnO4 minus is permanganate. Only one negative charge is there on permanganate, but two negative charges are there in manganate. So remember this. Okay. And one more thing is per. The word per is added for one, so it means permanganate. Okay, like we also say na peroxide, superoxide, like that. Okay. Next, MnO4 minus is stable only in strongly alkaline medium. In acidic, neutral, slightly basic medium, it also disproportionates. Okay, so MnO4 minus will disproportionate to give MnO4 minus plus MnO2. So this is MnO4 minus is plus 7 oxidation state, and MnO4 minus, which is manganate, it is in plus 6 oxidation state. However, we also get a pyrolusite substance which is MnO2, which is in plus 4 oxidation state. So we are going to study about my permanganate in more detail. Preparation of potassium permanganate, MnO2, we will get manganate ion, and then in alkaline electrolytic oxidation in alkaline medium we will get permanganate. Okay, so cathode में क्या है, हमारे पास H2 gas है. Now let's move ahead. This is how we will get magnate. Okay, this is the preparation, and this is what H2SO8 we also studied it before, where I'm unable to remember where we studied. We will again study this in P block in detail. This is known as Marshall's acid. This peroxodisulfate. Peroxodisulfate. Okay, yes, this is the structure of peroxodisulfate. Here it is the peroxy linkage. Okay, peroxy linkage. Next, let's move ahead and study further properties of potassium permanganate, color and melting point. Yes, we already know the color of potassium permanganate is purple. It is dark violet crystalline solid. Melting point is 523 Kelvin. Okay, so properties of potassium permanganate. It is also isostructural with KClO4. It is isostructural with KClO4. Okay, so this is what we have permanganate. Okay, and here it is KClO4. all these two are tetrahedral, and the color for this is due to LMCT, ligand to metal charge transfer. Properties of potassium permanganate: solubility. Solubility, fairly soluble in water, giving a purple color solution, right? And this is also used for titration. Okay, it is used as indicator. Action of heat: when heated strongly to 513 Kelvin, it decomposes to give oxygen. 2KMnO4 gives K2MnO4 plus MnO2 plus O2. KMnO4 manganate permanganate will give potassium manganate and MnO2 plus O2. This is the lab method of O2. Yes, we can also get oxygen on through this process, and this is the lab method to prepare oxygen, right? Action of alkalis now. So when any alkali like KOH, when reacts with KMnO4, it will give us K2MnO4 plus 2H2O plus O2. So K2MnO4 is potassium manganate. Okay, so what the same things we have discussed when we were studying dichromate, right? So how dichromate is formed? Dichromate is formed from potassium chromate, right? Now when we react it with potassium, when we react potassium dichromate with any alkali, we will again get potassium chromate. So in the similar way, we can also do the same thing with potassium permanganate. When it is reacted with an alkali, we will get the reactant back, that is potassium manganate. And on adding any acid to potassium manganate, we will get potassium permanganate. So these are the reactions also and the method to prepare, right? Now oxidizing character: powerful oxidizing agent. Acidic medium: 2KMnO4 plus 3H2SO4 plus will give K2SO4 plus 2MnSO4 plus 3H2O plus 5O. Basic medium, we will go this, and this is what we will be having when it will react with neutral medium. These are like, if they are across, then I don't think these are the things to remember. Now let's move ahead with some things. MnO4 on acidic medium will give Mn2 plus. Here n factor is 5. N factor means plus 7. The oxidation state is going from plus 7 to plus 2. How many electrons are gained? 5. And that's why in this we will be getting N factor 5. In acidic medium, MnO4 minus will give Mn2 plus. In basic or neutral medium, we will be getting MnO4 minus MnO2. Okay, MnO2. In highly basic medium, we will be getting manganate. Okay, simple. Highly basic medium, we will be getting manganate. This thing we know, right? And these two things, upper two things, we don't know. So we need to remember this. When we will be having any acidic medium, we will be getting Mn2 plus. When there is slightly basic or neutral medium, we will be getting pyrolusite ore. This is MnO2 and oxidation state is plus 4, and hence the N factor is coming out to be 3, right? And in this case, when we will be reacting it with highly basic medium, we will be getting N factor as 1, because the product side we will be getting manganate, which is in plus 6 oxidation state. Okay, so properties